All right, guys, before we get started, are there any questions over any of the assignments thus far? Question over any of the homework assignments? 4-1, 4-2, 4-3-1, 4-3-2. Because we've had 4 assignments thus far. Now, just time-wise, we're skipping 4 for now. We will come back to it if we do have time. But I want to go on and get to 4-5 and 4-6 first. In 4-5 and 4-6, what we're starting with these are actually solving higher degree polynomial equations. We're trying to find the values of x that will make the function be 0. Now, there's 4 main ways that we can solve these polynomial functions. And the first one is factoring. We can factor them. If there is a greatest common factor, we can pull it out and solve these here. Now, some of the special ways for factoring we're not going to look at for this here, but it is solvable in other ways. The second method is graphing, because if we can graph the polynomial function and it crosses the x-axis, that is going to be a 0 for the polynomial function. And we've done these. We've factored with quadratics. We've graphed with quadratics. We can graph with these higher degree polynomial functions. And the other 2 ways we know to solve are the quadratic formula and completing the square. Now, the quadratic formula and completing the square only works with functions that are degree 2, quadratic equations. So we'll have to use these other methods and learn some more to be able to get it down to a degree 2. Because if we can get it down to a degree 2, we can either use the quadratic formula, completing the square, or we can factor it. Because most likely, if it is graphable and we can find all the solutions, then we don't need the quadratic formula to completing the square. So, these are the ways we know so far. We will pick up a few others in this section and the next, but these are the main ones that we have for now. Now, if we look at this first one here, solving this one here. Solving by factoring. So we have 2x squared, not 2x squared, 2x cubed minus 12x squared plus 18x is equal to 0. And when we factor, we get to multiple sets of parentheses equals 0. And whenever we multiply 2 or more things together that equal 0, one of them must be 0. And whenever we factor, the first step is to find the greatest common factor. So when we multiply, when we're solving by factoring, the first thing we need to do is see if there's a greatest common factor. And if there is, we need to factor it out. So if we look at these 3 terms, 2x cubed, 12x squared, and 18x, well, all 3 of them do have a common factor of 2, yes, and x. Because 2, 12, and 18 are all divisible by 2. X cubed, x squared, and x do all have a common factor of x and 2. And if we factor this out, 2 factored out of 2 will factor out completely. And if we remove an x from x cubed, we're left with x squared. Minus, if we factor 2 out of 12, 12 divided by 2 is 6. And if we take 1x away from x squared, we're left with x. Plus, 18 divided by 2 is 9, and the x factors out completely, leaving us with 2x times x squared minus 6x plus 9. Now our x squared minus 6x plus 9 is factorable. One reason that we know that it can possibly factor is the x squared, because if there's an x squared term, there's a good chance it is factorable just because we have a power of 2. Now, there is another way that we can find this or determine if it is factorable, and that's using part of the quadratic formula, or b squared minus 4ac, where a is the term in front of x squared, b is the term in front of x, and c is our 9. Because if we plug it into this here, this part of the quadratic formula, and we get a whole number, a non-decimal real number, then it will be factorable. And in our case here, if we type this in, second square root, negative 6 squared minus 4 times 1 times 9, we get 0. So what it's telling us is this here, x squared minus 6x plus 9 is factorable. It's just telling us factorable. If it's a non-decimal number and it's a real number, then it is factorable because the b squared minus 4ac is half of the quadratic formula. And that square root part's really telling us if, or kind of what type of solutions we'll have, because if this comes out as a decimal number or as a non-real number, it means it's not going to be factorable in the sense that we need. Now at this point here, we factored out the greatest common factor. Our next step is to see if we can factor the other parts. And here, our x squared minus 6x plus 9 is factorable. So we have our two sets of parentheses with 3 spaces. We look at the sign of the third term. If the third term is positive, the signs are the same and match the sign of the middle term. If the third term is negative, our signs are opposite. Here it's positive, so the signs are the same and match the sign of the middle term, which is negative. So we have negative and negative. Our factors of x squared, well, the only two things multiplied to give us x squared is x and x. And lastly, our factors of 9 are 1. And which one do we want to try first? 3 and 3. Now we can check this off to the side and see if we have the correct set of factors. X times negative 3 is negative 3x. Negative 3 times x is negative 3x. And negative 3x minus 3x is negative 6x, which is indeed the middle term we wanted. Questions on this here so far? Now at this point here, we have 3 things multiplied together equal 0, so one of them must be 0. Either 2x is equal to 0, x minus 3 is 0, or x minus 3 is 0. Now for the first one, 2x equals 0, we need to solve this for x. And we can do that by dividing both sides by 2. 2x divided by 2 is just x. 0 divided by 2 is 0. So one of our solutions for this here is that x is equal to 0. Now we can look at x minus 3 is 0. So here we can add 3 to both sides. Minus x is equal to 3. And lastly, our other equation for this one here, just like the one before, we'll add 3 to both sides. Negative 3 plus 3 is 0, telling us x is equal to 3. So our 3 solutions for this here are x equals 0, x equals 3, and x is equal to 3. Questions on any of this here? Questions on anything we've done so far? At this point here, if we wanted to check our solution, we want to see if these do indeed work. All we have to do is plug these back in for x. So if we check to 0, so you have 2 times 0 to the third minus 12 times 0 squared plus 18 times 0. Well, 0 to the third is still 0. 0 squared, 0 times 0 is still 0. And 18 times 0 is 0. 2 times 0 is 0. 12 times 0 is, well, 0. And 0 minus 0 plus 0 is indeed 0. It really didn't tell us much. But 0 does work. We can do the same thing with 3. We can do 2 times 3 squared minus 12 times, or not squared, 12 times 3 cubed, negative 12 times 3 squared plus 18 times 3. Let's see if this does equal 0. Now, 2 cubed is 27. 3 squared is 9. And our 18 times 3 is 54. We're just checking it. 2 times 27 is 54. Negative 12 times 9 is 108. Plus 54. And if we solve this here, that'd be negative 54. Plus 54 is indeed 0, so it works. And again, we could have typed this whole thing into the calculator and let it do it for us, and it would have shown us that it does equal 0. So those are the solutions. Questions on this so far? So let's look at another one with factoring before we move on to another way to solve these. So again, with factoring, any of these here, we're just looking for greatest common factor, what will go into all three terms. Because 5x cubed, 40x squared, 80x, well, 5 will go into all three terms because 5 goes into 5, 5 goes into 40, and 5 does go into 80. And they all do have a common factor of x. And if we factor the 5 and x out of 5x cubed, we're left with x squared. Minus 40 divided by 5 is 8. And if we take an x away from x squared, we're left with a single x. Plus 80 divided by 5 is 1/6. And the x factors out completely. Part of the reason we're doing this is, one, factoring an x cube or a cubic equation. We do not have a method for that. But once we take away the 5x, that greatest common factor, we are left with this quadratic, which we do know how to factor quadratics. And this one here is indeed factorable. So we'll have 5x times our two sets of parentheses with 3 spaces. Because the simpler we can get this, the better. And it's easier to solve. Because if we can set it up as 3 things multiplied together, we know one of them must be 0. So we'll definitely have 5x is equal to 0. And our two other expressions equal to 0. So the next step we're doing, or the next part of this, is factoring our x squared minus 8x plus 16. Since the third term is positive, our signs are the same and match the sign of the middle term, which in this case would be negative and negative. Guys, our factors of our first and third term, factors of x squared, are going to be x and x. Factors for 16, well, we have a few. We have 1 and 16, 2 and 8, 4 and 4. Which ones do we want to try first? 2 and 8. And we can check this here. X times negative 8. Negative 2 times x is negative. And negative 8x minus 2x is negative 10x. Is that the middle term we wanted? No. We can try 4 and 4. We check this here. X times negative 4 would be negative 4x. Negative 4 times x would also be negative 4x. And negative 4x minus 4x is negative 8x. Is that the middle term we wanted? So we do have it factored. And again, at this point, we have 3 things multiplied together to equal 0. So one of them must be 0. Well, once we solve for x, yes. Because we do have 3 things multiplied together equals 0. We get it here so that they're easier to solve. because trying to solve this straight out and just seeing what x is a little difficult. But if we can factor it down to this here, 5x times x minus 4 times x minus 4, well, one of them has to be 0. That's the only way we can get it equal to 0 and have three things multiplied together. That means either 5x is 0, divide both sides by 5, just telling us x is 0, or x minus 4 is 0. So here we can add 4, telling us x. So either 0 or 4 will make this true. And the last one, we can add 4 to both sides. So x is either equal to 4, or 0. Five times 0 minus 40 times 0 squared plus 80 times 0. We can type it in and see if this equals 0, and it does. We can do the same thing with 4. Minus 40 plus 80. Ah, that's why. It should be cubed, not squared. 5 times 4 cubed minus 40 times 4 squared plus 80 times 4 does equal 0. Questions on factoring with these here? Because if we can factor them, get them factored, set them equal to 0, we're able to solve. Now the other way we can solve these is by graphing. Negative 2x to the fourth plus 16x squared minus 32. So we can grab the graphing calculator and hit y equals. So it might be good to try and make sure y'all can plug these into the calculator with graphing, because that does help. So the first thing we're going to do is hit y equals. If there is something typed into the first one or any of them, I would clear it out. And we're going to type this in. So our negative 2x to the fourth plus 16x squared minus 32. Negative 2x, and then our caret key to the 4. And then 4. Plus 16x squared minus 32. We're able to type it in. We're able to get the 4 power. Arrow. Able to get it typed in. Okay. It'll be the last week. Okay. So the videos and assignments will be posted to Google Classroom. Are we able to get this typed in? Yes. Now at this point, we're going to hit graph. Hit zoom up in the top center. 6.
Do you know how to do college math still?
I do. So, looking at this here, where it crosses or intersects the x-axis are the solutions. And if we go second graph, we pull up the table. We're trying to see what values of x will make the y value be 0. And we see that there's two of them. -2 and 2, because we're looking for what values of x will make the y value be 0. Now, the y-intercept is at 0, -32, but we're mainly looking for x-intercepts. We're looking for what value of x will make the y value be 0. And we found two of them. So we know x is indeed equal to 2, and we know x is equal to -2. Now for this here, those are not the only values. There are actually a few more, but those are two of the solutions. Now one thing that we did miss out on in 4.4 is the factor theorem. The factor theorem states that a number or value is a solution if the remainder when dividing is 0. Because if we do long division or synthetic division, and the number we plug in is 0, if the remainder is 0, the number we get over here is 0, then it is a solution, and it also means that it is a factor. So in this case, x plus 2 and x minus 2 would be factors. And we could do this here, and we need to do this to be able to find all the solutions. And for this one here, there are 4 solutions. And we'll get to the reasoning behind that more later. But here, well, -2 and 2 are the solutions. It just works out that there are repeated twice. And we'll show that and see how they are repeated twice. Now with the factor theorem, we'll go through and do the division. 2 times -2 is -4. 0 plus -4 is -4. 2 times -4 is -8. 16 plus -8 is 8. 2 times 8 is 16. 0 plus 16 is 16. And 2 times 16 is 32. And lastly, -32 plus 32 is 0. Now we can do this division again with -2, our other solution. -2 times -2 is 4. -4 plus 4 is 0. -2 times 0 is 0. 0 plus 8 is 8, and -2 times 8 is -16, giving us a remainder of 0. Now we knew, or should have known, that the remainder would have been 0 on both because they are solutions. Since they're solutions, it means they are factors. And if they are factors, the remainder will be 0. And if we plug our variables back in, the 0 in the box is the remainder. Our 8 is the term without x. 0 is the term with x, and -2 is the term with x squared. So after dividing those two terms out, those two solutions, it tells us that our final, or what we have left, is -2x squared plus 8 is equal to 0. Now this might seem a little much or a little excess, but what this has done is it's taking it from a degree 4, fourth degree polynomial function, down to a quadratic, a degree 2. And this is helpful in a few ways because now it's easier to solve. We know how to solve this here. And specifically, we can solve it by the square root method. And the reason we know we can solve it by the square root method is because there is no middle term. We can subtract 8 from both sides. Telling us -2x squared is equal to -8. We can divide both sides by -2. telling us x squared is equal to 4. And lastly, we can take the square root of both sides, telling us x is equal to plus or minus 2, which is really just saying that x is equal to 2, 2, negative 2, and negative 2. We just have those repeated. And we don't talk too much about it in this class, but it is true that whenever we look at a graph, because we talked about, actually we did talk about this in chapter 3, that anytime the graph touches the x-axis but does not cross, it has an even multiplicity, which means the number of zeros at negative 2 and at 2, when x is negative 2 and when x is 2, is repeated, in this case, twice. They're always repeated an even number of times, which means with the synthetic division, I could have done 2 or negative 2 twice and got the same results. Questions on this here? Let's look at another one. X to the 4th minus 18x squared plus 81. And we're going to solve this by finding the zeros. Well, again, let's grab the graphing calculator and graph this. So the first thing we're going to do is hit y equals, and we can clear that out. So the first thing we want to type in is x to the 4th. So x caret 4, x, our exponent key 4, minus 18x squared plus 81. Questions on how we type this in? Are you all able to get that typed in? Now the next thing we're going to do is hit graph. And as we look at this here, we see that it intersects the x-axis in 2 places. Question? Are you able to get the graph? Now we can go second graph and look at the table. And again, we're trying to see what values of x will make the y value be 0. Negative 3 and 3. Now it does look like they intersect the x-axis but do not cross it, so there's a good chance there might be more than 1 0 at that location. So negative 3 might work twice, as well as 3. And we can do this by starting off with 3 or negative 3, it doesn't matter which, to make sure we do have all the solutions. And our numbers going across the top, we'd have 1 for x to the 4th, 0 for x cubed, negative 18 for x squared, 0 for x and 81. Then we can bring down the 1 and start doing our synthetic division. 3 times 1 is 3. 0 plus 3 is 3. 3 times 3 is 9. Negative 18 plus 9 is negative 9. 3 times negative 9 is negative 27. 0 plus negative 27 is, well, negative 27. And 3 times negative 27 is negative 81. And since the remainder is 0, it confirms that it is a solution. It is a factor, as we saw with graphing. Now, as we said also, there's a good chance that we do have a repeated solution at 3 and negative 3, because it did not cross the graph. It looks like it hit the x-axis and went back. So we can try 3 again, because if this remainder is indeed 0, it means 3 has a multiplicity of 2. It showed up twice. Now our 3 times 1 is 3. 3 plus 3 is 6. 3 times 6 is negative 9 plus 18 is 3 times 9 is, and negative 27 plus 27 is indeed 0. So it means that 3 was a solution twice. Now, at this point here, there's 2 ways we can go about this. One is we can put the factors, or not factors, our variables back in. because we would have 9, 6x, and x squared. So at this point here, we took it from our x to the fourth minus 18x squared plus 81. We did synthetic division twice, which reduced the degree by 2, and gave us x squared plus 6x plus 9. Well, x squared plus 6x plus 9 is something we've done before. We've factored this. We've solved these here. But if we run out of solutions that we were given by graphing? Well, no, we still have negative 3, yes? So let's do synthetic division one more time and see what we get. So we set it up. We bring down the 1. Negative 3 times 1 is 6 plus negative 3 is negative 3 times 3 is 0. So negative 3 is a solution. And let's see what we have left. Remainder. 3 is our constant. 1 is our term with x. So when we did this one more time, we're told that we're left with x plus 3. We did synthetic division 3 times and took it from a degree 4 down to a degree 1. If I want to solve this at this point, all I need to do is subtract 3, telling me. So our solutions are that x is negative 3, 3, and 3. Questions on this here? We do have time for one more. We won't be able to finish this note sheet today, but I do want to finish up on this one here. Let's start off by typing it into the calculator. So we have 4x to the fourth minus 40x squared plus 36. Questions on how we type this in? Next thing we can do is hit graph. Well, this one here, we have 1, 2, 3, 4 places it crosses the x-axis. And if we hit second graph, our 4 solutions are negative 3, negative 1, 1, and 3. Equal to negative 3. X is equal to negative 1. X is equal to 3, and x is equal to 1. And that's it. Those are all 4 of the solutions. Because for this here, this 4th degree polynomial expression, when we graphed it, we saw that these are the solutions. These are our 4 answers. I could verify it with synthetic division, is that I could pick 1, 4, 0, and do this here, because as we do each one, it will decrease the degree by 1. And as long as the remainder is 0, it is a solution. And if we go through all of them and none are left, we get back down to a degree 1, solve it, and we have all the solutions. Then we're done. That's it. Just verifying that they are the solutions. Negative 3 times R4 is negative 12. 0 plus negative 12 is negative 12. Negative 3 times negative 12, the negative times a negative is a positive. And 3 times 12 is 36. Negative 40 plus 36 is negative 4. Negative 3 times negative 4 is 12. 0 plus 12 is 12. And negative 3 times 12 is negative 36, which does indeed give us a remainder of 0. One of the other solutions we got was 3. 3 times 4 is 12. Negative 12 plus 12 is 0. 3 times 0 is 0. Negative 4 plus 0 is negative 4. And 3 times negative 4 is negative 12. And negative 12 plus 12 is indeed 0. So doing the synthetic division, we've been able to show that 3 and negative 3 are both zeros. We'll do the same thing with 1. 1 times 4 is 4. 0 plus 4 is 4. 1 times 4 is 4. And negative 4 plus 4 is 0. At this point here, we can put the variables back in because now we're back to a degree 1, telling us that all we have left is 4x plus 4. And if we solve this here, first thing we would do is subtract 4, telling us that 4x is equal to negative 4. Divide both sides by 4, telling us x is negative 1. So it did confirm that our 4 solutions for this here are negative 3, 3, negative 1, and 1. Well, we'll stop there for today, and we will continue this